Hello there, it's great to see you again. What we're going to do in this video is solve the equation 5 cosine x plus 4 equals 0, where x is between 0 and 2 pi radians, not including 2 pi. So the first thing we need to do in an equation such as this is an equation that is linear in cosine x. So we need to solve the equation first for cosine x, isolate cosine x to one side of the equation. And by doing so, we have cosine x equals negative 4/5. Now, negative 4/5 does not correspond to a special angle, which means that the solutions we get will need to be approximate. So this means that x is equal to the inverse cosine of negative 4/5, and to 2 decimal places, that is approximately equal to 2.50. So that's one of our solutions. Now, we do know that in one full revolution, which is 0 to 2 pi, one full rotation on the unit circle, that there are two values for which cosine x could be equal to negative 4/5. 2.50, as we can see, is a quadrant 2 angle for two reasons. We know that the inverse cosine function returns a value between 0 and pi. If the argument is positive, that means we have a first quadrant angle. If the argument is negative, that'll be a second quadrant angle. We also know this because 2.50 is between pi over 2, which is approximately 1.57, and pi, which is approximately 3.14. So that means that this angle is a little closer to 3.14 than it is to 1.57. So here is our first solution. So this is x equals 2.50. To find the other, we need to find the reference angle and then figure out the other quadrant that contains our solution. Well, if cosine has a value that's negative, we know that happens in quadrant 2 and quadrant 3. So that means my other solution is here, and I need to know what this reference angle right here is. Well, I know that this is pi, and I know that the first solution is 2.50. So the reference angle is the difference between pi and 2.50, which is about 0.64. So to the nearest hundredth, my reference angle is 0.64, which means this has to be 0.64. The same reference angle gets used in all four quadrants, and that means that our other solution is x equals pi plus 0.64, which to 2 decimal places is 3.78. So our approximate solutions to 2 decimal places are 2.50 radians and 3.78 radians.